everyone, my name is Angelica, and today I'm going to talk about the reproductive potential of seahorses. First, as we know, in most animals, the mother plays an important role of reproduction, and they were pregnant and born the babies, and some of the parents will take care of the babies until they grow up. But interesting, in seahorses, the fathers do this kind of hard work, and they have a brood pouch, and they can protect and provide the nutrients for the babies so they can grow up more better or healthier. And when the mating happening, as we know, the male will provide the sperm, and the female will provide the outside. So the embryo size was depended by the mother because of the outside. So if the outside size is bigger, and the embryo size will be bigger too. And this is the embryo. And what we want to know is, and what will cause the size difference of the baby seahorse? Juveniles means the baby seahorse. Juvenile means the baby, and in this case, it means baby seahorse. And does the female or male size cause these differences? And in this research, we choose a hippocampus gyrolatus seahorse, and it is a kind of the long snout seahorse. The snout means the nose and the mouth, like this. So this is the snout, and this is a long snout seahorse. And the seahorses were collected by scuba diving in Ria Formosa Lagoon. And this is the seahorse, and here is where the lagoon is, and it's in Europe. And how can we get that we want to know? And we set up 3 experiments. One is methylation, and the second is reproductive potential, and the third is paternal contribution. Paternal means the fathers. So paternal contribution means the fathers cause the contribution. And at the mate selection part, we prepare 3 boxes to raise the seahorse. And each boxes will have 4 seahorses with different size and sex ratio. For example, in the first boxes, we will have a large and a small female, and a large and a small males. And the second will have a large and a medium and a small female with the medium males. And the third will have a medium female with a large, a medium, and a small male. And this is the sex ratio. The left is the female, and the right is the male. And the seahorse behavior will be recorded, and we can know how they're mating. And as I told before, the female will provide the outside when they are mating, and the outside size will be an important role of the embryo size. So the reproductive potential of the females are decided by the outside, like this, and this is the outside. And the reproductive potential of the males were based on the juvenile's number and size. So in this part, we will measure the outside size and the juvenile's number and size, and to compare. At the last, the water depth is an important, is a reason that will influence the reproduction. And each pair, we will let them make 2 times, and one is in a deeper water depth, and the second is in the shallow water depth. And the transformation of outside from the female to the male pouch will occur at the same time when the pairs rise to the water surface, like this. So the transformation will be interrupted when they reach the water surface. So it will stop at here, and we can see that again, like this. So the stop here, and up and stop here. And the juveniles will be weighed and measured too. Okay, so let's see the 3 parts of the experiment's results. First, when the seahorses wanted to mate with another seahorse, they would prefer to choose a similar size or a larger mate. And the male will choose the larger females so they can get a bigger outside. And the females will select a large or a similar size of males so it can get a bigger brood pouch. And it is all in order to optimize their juveniles and avoid it of wasting egg. And that's the reproductive potential of the females. In this 3D picture, we can see the x-axis of all is female size, and the y-axis is respectively egg volume and yolk volume and yolk proportion. And the yolk proportion means the yolk volume divided by the outside volume. And we can see the left is the small females and the right is the larger female. So at the egg volume and the yolk volume, we can see that the larger female will have a bigger volume. So the bigger female will have a bigger egg, so they can provide more nutrients for the babies. And because of this difference of egg and yolk volume, so the yolk proportion were not the same. And as I told before, it is the reproductive potential of male will have a different decided way. And first, it is easy to approve that the bigger male will have a bigger brood pouch, right? So does the data tell us. In this picture, the x-axis is male length, and the y-axis is the pouch volume. So we can obviously see that they have a positive relationship. So it means that the larger male will have a bigger brood pouch, so they can approach more juveniles. But the brood size has no relationship between the brood pouch size. The brood size means the number of the juveniles. So this is the bigger brood size, and this is the small brood size. And in this picture, we can see the x-axis is the brood size, and the black spot means the male length, and the gray spot represent the pouch volume. And we can see that there are no relationship. So we observe another data, and we can see that the embryo density have a negatively relationship with the male length and the pouch volume, like this. So it means that when the pouch volume is bigger and the embryo density will be lower. So in a lower density, the embryos will have more space to grow up. So it is an important point that we think if the bigger male can pouch the bigger juveniles. And as the evidence I showed before, the higher water depth have a longer time to transport the oxide. So in this picture, the y-axis is the oxide number, and this is the higher water depth. This is the lower water depth. So we can see that the higher water depth have more oxide, and the lower water depth has less oxide number. So we can know that at same seahorse, the higher water depth the brood pouch will have a higher density, and the lower water depth have a lower density. So because the higher water depth will produce a smaller juveniles, and the lower water depth will have a bigger juveniles. So I made a conclusion of this part of the experiment. These two seahorses are the juveniles. So we can see that in a larger brood, we'll have a bigger brood size and a higher embryo density, but the smaller juveniles. And the smaller brood will have a less juveniles and a lower density and a bigger juveniles. So we can know that the bigger brood will cause the smaller juveniles. So in discussion, we can know that when a seahorse mating, they will prefer to choose a similar mate size. The larger female will not choose the small males, and the larger males will not choose the small females too. And if the parents are bigger, the outside size and the brood pouch size will be bigger and cause the embryo density lower, and the size of baby will be bigger too. And this is a female seahorse, and this is a male seahorse producing the babies. So the conclusion is size doesn't matter. And this is my presentation. Thanks for listening.